So for what value of b is g of x equal to x if x is less than negative 2 and bx squared if x is greater than or equal to negative 2. Continuous at every x. So here, the point that we're interested in looking at is at negative 2. Because outside of negative 2, we have two polynomials. The one polynomial is x, which is always continuous, and then the other one is bx squared, and that's always going to be continuous. So negative 2, you want to think of it as connecting these two functions at x equals negative 2. So in order to connect these, to make it continuous, you want the limits to be equal at negative 2. So we're going to be looking at negative 2 to the left and negative 2 to the right. Now, negative 2 to the left will be the top equation because here x is less than negative 2. And then x approaching negative 2 from the right will be the function that has x greater than or equal to negative 2. And that'll just be bx squared. I'm going to plug in x equals 2 now, or negative 2, and I get negative 2 is equal to 4b. So b is going to be negative 1/2. So it's going to be continuous when b is equal to negative 1/2. Let's look at what this looks like. So to the left of negative 2 is going to be the graph y equals x. So it's going to look something like that. And to the right of it is bx squared, which we said is negative 1/2 x squared. So it's going to be a parabola facing down, and it's going to be connecting at this hole here. It's going to look like that. And really, it makes sense now to see that, well, this is the only point that we're interested in to see if it's continuous. Because clearly, everywhere else, it's going to be continuous. So, those are good. Let's look at another example. For what values of a is f of x equal to a squared x minus 2a if x is greater than or equal to 2 and 12 if x is less than 2. So in order for this to be continuous, the left-hand limit has to equal the right-hand limit. So the left-hand limit is when x is less than 2, so we're going to say x approaching 2 from the left of 12. And the right-hand limit, we will be using the a squared x minus 2a, since x is greater than or equal to 2. I'm going to plug in x equals 2, and from the left here, we see that 12 is a constant, so it's regardless where you're approaching it, it's always going to be 12. And to the right, I could just plug in x equals 2 to get 2a squared minus 2a. I bring the 12 over, factor out a 2, and I can now easily factor the equation. I get two nice factors. I want a minus 3 to be 0, and I want a plus 2 to also be 0. So that would give us 3 and negative 2. So that means there's going to be two solutions here. When a equals 3, my f of x is going to be continuous. And when a is negative 2, my f of x is going to be continuous. So let's see what that looks like. If I were to graph this, I know I'm going to be at x equals 2, to the left of 2, sorry, it's going to be 12. And then to the right of 2, we have a squared x minus 2a. And when a is equal to 3, we get 9x minus 6. So when I plug in x equals 2, 9 times 2 is 18, minus 6 is 12. And that's going to be with positive slope. So it's going to look something like that when a is equal to 3. And now when a is equal to negative 2, let's see, I plug in negative 2, and for a I get 4x plus, let's see, 4. And that's going to be, when I plug in x equals negative 2, I get negative a plus 4. Sorry, when I plug in x equals 2, I get 12 as well. And that one's going to have a lesser slope, so it's going to be something like that. Okay, so it's still going to be a positive slope, it's just not as steep. So those are the two cases that make f of x continuous at x equals 2. Let's look at another example now. Here we'll be looking at another step piecewise function. So we want, for what value of b is g of x equal to x minus b over b plus 1 if x is less than 0, and x squared plus b if x is greater than 0. So I'm going to be looking at the left-hand limit and the right-hand limit, and I want to set these equal to each other. So I'm going to plug in x equals 0 for x minus b over b plus 1 to get negative b over b plus 1. And then x equals 0 for x squared plus b to get b. So I'm going to multiply the b plus 1 to get negative b equals b squared plus b. And that's going to be b squared plus 2b equal to 0. Factor out a b, I get b plus 2. And now I want b to be 0 or b plus 2 to be 0. So that means b has to be 0 or negative 2. So I'm going to get two different answers here. So both of these will make it continuous. And the graph is very similar to the previous answer, or the previous question, because we had quadratic, but the other one was a constant, but this one is just going to be a line. So it's going to be very similar. Okay, now let's look at a piecewise function that has three different functions. So it's going to be negative 2 if x is less than or equal to negative 1. Ax minus b if x is between negative 1 and 1. And 3 if x is greater than or equal to 1. So you want to see when it's continuous at every x. The points of interest are going to be a negative 1 and 1 for here. Because everywhere else, it's either going to be constant or a linear function. And we don't have to worry about those being continuous or not. So we're going to have two cases. We're going to look at when the limit as x approaches negative 1 from the left and the right. And we're going to want those two to be equal. And we're also going to look at the limit as x approaches 1 from the left and the right. And we're going to want those to be equal. From the left, we're going to look at the function where x is less than negative 1, less than or equal to negative 1, which is negative 2. And from the right, we're going to be looking at the function that is defined between negative 1 and 1, which is ax minus b. So I could just plug in negative 1 for both. Because the left one is a constant function, it's always going to be negative 2. And to the right, I can just plug in negative 1. I get negative a minus b. To the right, now I'm be looking at the limit as x approaches 1 from the left, which is going to be the ax minus b equation, since x is between negative 1 and 1. And as x approaches 1 from the right, that's just going to be 3. So I'm going to plug in x equals 1 to get a minus b equals 3. And now I have two equations and two unknowns. So I have a system of equations. I have my a minus b equals 3. And my negative a minus b equals negative 2. And here I can just rewrite this as a plus b equals 2. Just multiply everything by negative 1. I can now add these two equations. So I get 2a equals 5. A would be 5/2. And I can plug in a equals 5/2 into, let's say, the bottom equation. Or let's do the top equation. So we have 5/2 minus b equals 3. I'm going to subtract 3, and I'll get b is equal to negative 1/2. So my final answer would be a is 5/2, and b is negative 1/2. And that would make my f of x be continuous.